We might have been seeing these 7-segment LED displays. It is pretty common in some electronic device like digital clock, multimeters, thermometers and various other electronic things, and it is very easy to use. Although the name is 7-segment display, it is a device of 8 LEDs and can be in configuration of common anode or common cathode. You just need a current limiting resistor like I used 220 ohms in the anode pin and connect the ground to the appropriate pin to display the segments. Mine one is common anode and the pin 3 and 8 or the middle pins both on the top and the bottoms are common anode and the rest are the cathode for different segment LEDs. I have mapped them in the following manner. Upright and the followings are A, B, C and D and bottom right to left are dot E, F, G. And the pin 1 is connected LED segment A, pin 2 is connected LED segment B, pin 4 is the LED segment C, pin 5 is the LED segment D, pin 6 is the LED segment dot, pin 7 is the LED segment E, pin 9 is the LED segment F and the pin 10 is LED segment G. When any segment ground pin is connected to logic 0 or ground, the LED lit up and set up the pattern of digit if the pins are chosen correctly. So, to display English numerals on the display, specific set of pin has to pull low or high in voltage like binary byte according to the 8 segment pins. So, I finish the byte map for which digit 1 will be displayed if the segment pins are set as the bit of byte 0 1 1 1 1 0 1 1. Thus, for digit 2, the byte is 00101100 and here are the others. When I know all the data of the byte map, I grab an Arduino and connect the display device to the Arduino pins 9 to 2 and 5V to the anode through a resistor and created a rough Arduino sketch. Here I have defined the digits as a sets of byte array and using the for loop set the pin to low or high one by one with a delay of 1 second. Then this crude Arduino sketch is uploaded to the Arduino and here is the results. The counting up of the digits indicates that the theory discussed above is applicable and it is correct. But if we look at the Arduino and count the available pins for other process, it is less. Moreover, we can't use the 4 out of 6 PWM channels with this setup, and single digit isn't enough. If we need more display units, we can't connect and control them using the microcontroller. Therefore, we need other options to look on, and here is the way out, using a serial in parallel out shift register. The IC 74HC164 is a shift register which will drive the display segment with the combination of shift out function of Arduino library. A shift register makes an output of logic high or low whatever input is available on the rising edge of the clock pulse and latched it in the first output. In the next clock cycle, it shifts the data one bit to the higher order and then shift again them in the next clock pulse. While there are multiple clock pulses with valid data like the byte map on the clock and data pin of the shift register, the output pin will have the same byte after each and every 8 clock pulse. The 74HC164 shift register has 8 pins, where pin 7 and 14 are for power, pin 1 and 2 are inputs and they are ANDed internally. Pin 8 is for the clock pulse input. Pin 9 is inverted clear input and pins 3 to 6 and 10 to 13 are the output from the shift register. The IC connections are pin 7 and 14 is ground and 5V respectively. Pin 9, the clear pin is high as it is active low pin. Pin 2 is high to enable the data. And the output pins of 74HC164 shift register QA, QB, QC to QH are connected to the display pins 8, 7, 6 to 1 respectively. As before, I have used a single 220 ohm resistor in series with the anode pin of the display device. I have used pin 2 and 3 of Arduino as the data output and clock signal which is connected to the pin 1 and 8 respectively and give the power to the circuit. It is interesting to observe that if you touch the data pin 1 with your finger, the circuit takes it as input and shifts it towards the digit display and the random patterns appears. It is fun. Then I have created the following sketch to upload. The shift out function shifts the 8-bit values accordingly in the data pin 2 and clock pin 3. So now the device can display any of the digits instantly but using less pins than earlier. And the interesting thing is now we can use a second unit just using another 74HC164 IC to completely display 2 digits number. And the connections of the IC are same as before in this case, and no extra Arduino pins are required. The input pin of the second shift register pin 1 is fed with the output pin QH or the last data output pin of the first shift register to make a continuous 16-bit long shift register. Thus modifying the previous sketch a little bit, that is, another shiftout function next to the first shiftout function will shift the data 16-bit of the 2 data byte map to this 2 display unit appropriately. And here is the result. By this setup, the digit display can show any number between 0 and 99. And if you want more, as much display unit as required can be done using more ICs and no extra pin of Arduino. And this is all for this video. I hope you have learned something more on this basic. That is why please like, subscribe and share this video.